So yes, it's recording. The top left, you could see that recording symbol. Yeah.
Okay. Okay. Uh, so let us start something today, so that next class onwards we can go ahead. So this is unit number 1, introduction to heterogeneous reactors or reactions. So first we'll see how to write the rate equations for heterogeneous reactions. What are heterogeneous reactions? What are the different types of heterogeneous reactions? Then we'll see the adsorption, how to write the rates for the desorption. Then how to go for the rate controlling steps and all. So these are the objectives of this unit, and we'll start this heterogeneous reactions. Now, what is heterogeneous reactions? In heterogeneous reactions, you can see any reaction will have reactants. It will give you the products. Heterogeneous reactions is a reaction in which if the reactants and the products are of different phases, you call it as heterogeneous. Not only that, if a catalyst is present, then also you call it as heterogeneous. The reactant, the products and catalyst are in different phases, right? So if the reactant is a liquid and if the product is a liquid and if your catalyst is a solid, again you call it as heterogeneous reactions. Reactant can be gas, the product can be a liquid, but the catalyst can be a solid. Generally, catalyst will be solid generally, right? That is also a heterogeneous system. So any two phases involved other than one phase, then we call it as heterogeneous reactions. Not only that, the catalyst, even in absence of the catalyst also, if there is no catalyst, if the reactant and products are of different phases, like gas reactant or a solid reactant giving you the gaseous products, or gas reactants is giving you liquid products, or whatever combination it is, still we call it as heterogeneous. So the types in this heterogeneous system is, it can be a catalytic type heterogeneous reaction, that is a catalyst. The reaction is happening in presence of a catalyst. So the reaction should occur, a catalyst should be there. There can be one more type of heterogeneous system where there is no catalyst at all, like non-catalytic type heterogeneous reactions. So both you have to study. When there is a catalyst, the reaction is happening. When there is no catalyst, still the reaction is happening because of the different phases of the reactant and products. When it is like that, when the reactants and products are of different phases, how to write the rate expression and how to find out the conversion which is happening there. That is what this CRE2 is all about. Okay. So both you will be studying, right? So in this, there are two types: catalyst type heterogeneous reactions, non-catalytic type heterogeneous reactions. We'll see first catalytic type heterogeneous. Now, what do you mean by catalytic type heterogeneous reaction? There will be a reactant, there will be a product. Either the reactant can be a liquid, gas, or a solid, or the product also can have a solid, liquid, or a gas. Whereas the catalyst should be present. Generally, the catalyst will be solid form. It does not mean that solid catalyst should be only solid. It can be anything, but generally here For our thing, we'll go only for a catalyst that is of solid. So we'll see that catalytic type heterogeneous reactions. Again, there will be different combinations here. Catalytic type heterogeneous reactions can have a reactants, can have a products and a catalyst. The reactants can be liquid, solid, gas. Again, products can be liquid, solid, gas. So how many combinations will come? A liquid reactant on a solid surface can give you a gaseous products, or a gaseous reactant on a solid surface can give you a liquid. So different combinations will come. You know that permutations and combinations, right? So too many combinations will come. So we'll see one by one. So catalytic type heterogeneous reactions. First, let us see gas solid reactions. What do you mean by gas solid reactions? The phase involved is gas and a solid. Either it is reactant or a product or a catalyst. Understand? So you can see here gas solid reactions. Example is ammonia synthesis. What is happening in the ammonia synthesis? Can anyone recall that equation? N2 plus 3H2 gives 2NH3. Am I right? That is the ammonia synthesis equation. N2 plus 3H2 is a gas. It is occurring on a these two reactants are happening over a catalyst surface. That is vanadium not vanadium. I think it is Fe2O3. That's a salt. So these two reactants are sitting on a catalyst to take part in a reaction to give you ammonia. That is a gas again. So the gas solid reactions is again reactant is a gas. Product is also a gas, but the catalyst is solid, Fe2O3 or whatever it is. That is what we call as gas solid reactants. One more example is oxidation of SO2 to SO3 using vanadium pentoxide catalyst in the manufacture of H2SO4. If you remember that sulfur gets oxidized or sulfur is burned in presence of oxygen to give you SO2. SO2 is converted to SO3 in a catalytic converter, that is two-stage catalytic converter to give you SO3. Then SO3 is some of you can unmute yourself. I think it's fine. Okay. Yeah. SO3 is absorbed in water or H2SO4. If you absorb in water, you get H2SO4. Generally, it is absorbed in H2SO4 to give you volume, concentrated form. The volume will be diluted to give you H2SO4. That is the production. Especially this SO2 to SO3 is a reversible reaction. So this is happening both the gas phase. This is gas and this is gas. It is occurring on a solid surface, that is V2O5. So again, gas solid reactions, right? The one more is catalytic cracking of crude oil. Crude oil is a liquid, right? If you crack that crude oil in presence of a catalyst, you get different fractions of whatever you want, right? There is one more example of gas solid reactions. This is a catalytic because these reactions are happening in presence of a catalyst. Now we'll see one more. Gas, liquid, solid reactions. What does that mean? Gas is a reactant, liquid is the product on a solid surface, or liquid is the product, liquid is the reactant, gas is the product on a solid surface, or whatever it is. So you can see the examples. Catalytic hydrogenation of acetone to propanol. This is one very famous example for this. It is occurring on a catalyst surface, right? So catalytic hydrogenation of acetone to propanol. That is one example. The other example is catalytic oxidation of ethanol using O2 to acetic acid. This is also one more example of gas, liquid, solid reactions, whereas this is gas and solid reactions. Generally, whenever we put solid, here I am telling catalyst type, whatever we are discussing, generally we assume that the catalyst is solid. So whatever it is here, we are assuming that the solid is the catalyst. whereas the other phase is this two. Okay. Now we'll go for the second case. When there is no catalyst, assume that there is no catalyst now. Reactant is giving you product, but the reactions are heterogeneous in nature. That is, the reactions are happening without the presence of the catalyst. Without the presence of the catalyst in the sense, then what will happen? You get extra combinations, because here you are getting only two combinations, because solid is fixed for the catalyst. Only gas, liquid and gas solid, that is what is moving. Whereas if you go for a non-catalyzed heterogeneous reactions, too many combinations will come, because here there is no catalyst. That means solid phase is also can take part in a combination. Now you see gas, liquid, solid reactions. Gas, liquid or gas, solid reactions. Gas can be a reactant, liquid can be the product, or gas can be a product, reactant, solid can be a product, or solid can be a reactant, gas can be a product, or whatever combination it is. Right? So gas, liquid, solid reactions, you can see the examples of this. Combustion of coal. Coal is a solid. On burning, you will give you carbon dioxide. That is a gas. Again, roasting of sulfide ores. This is one more example of gas, liquid or gas solid reactions. Again, this gas solid is different. This gas solid is different. This gas solid is taking place in presence of a catalyst, whereas here the gas solid is taking place in the absence of a catalyst. Understand? So try to visualize and then write accordingly. 2 marks they will ask you. Give one example of gas solid non-catalyzed reactions, right? So especially when you are going for this MCQ, they will ask you that. They'll give you this and they will give you this also. You should understand. You should visualize inside that. Oh, this is taking place in presence of a catalyst. He's asking for a non-catalyzed reactions like that, right? This is example. One more example we'll see. One more classification. Gas liquid reactions. There is no solid part at all now. So the reactant can be gas, the product can be liquid, or the reactant can be liquid, or the product can be gas, whatever it is. Gas solid reactions, generally we go when this fifth unit, we will study more about this, right? Because gas liquid, that is gas is absorbed in the liquid, just like soda, right? Water, carbon dioxide in absorbed in water to give you carbonated water. So when you absorb gas in liquid, what will happen is the reaction will enhance. The reaction will enhance. So here there are two parts here. One is the absorption is taking place, that is the mass transfer is happening. The other one is due to the mass transfer happening, the reaction is also happening. The kinetics will change. Till now we saw only about the kinetic change. We never bothered about the mass transfer picture in that. So when there is a heterogeneous reaction, not only the kinetic part will play an important role, even the mass transport plays a very important role. That is why your kinetics equation, you get that extra mass transfer coefficient also into picture. That is the difference between homogeneous and non-homogeneous reactions. So you can see
Sir,
here. Yeah. Yeah, go ahead.
sir, just a minute. Sir, one of the participants, like Amrita Gadeshwaran, is telling that, yeah, that guy, sir, it's coming as something else, and he's telling that his hair is not letting me in. So can you add him in the group, sir? Like you could type it. I'll tell with Jesse.
What is his name?
Amrita Kadeshwar. AMIRKA. Yeah, the first one, sir. Yes, sir. That's him.
So what is happening when I add? It is coming as guest. Just I'll show you. I'll show you now. Because earlier Srinidhi, I did like that. It is coming like a guest. Amrita Ganeshan, right? Where is this? Is all member. Just see his name. This is a Amrita. Yeah, I think now it came as. Now it came as morning. It is coming like a guest. Okay, fine. Now he is joined. Na? Is he joined?
Sir, I joined, sir.
Okay, good. Because I'm not having any pending requests, but okay. Some new thing. Okay. Yeah. Shall I continue, Vignesh?
Yes, sir. Sorry for disturbing.
No problem. No problem. Because, yeah, this gas liquid reactions is a very important thing because your mass transfer or the reaction gets enhanced, whereas the other kinds of heterogeneous, your reaction rate will be decreased by the diffusion. To give you one example, I'll just give one example so that you will understand what is happening in the mass transfer. Now you take a coal, right? You take a coal. Let it be like this. You take a bunch of papers, right? You take a bunch of papers. You tie the papers and then try to burn the papers. What will happen? Yeah, I want some of your feedback. What I'm telling you is newspaper bundle, right? 1 month newspaper bundle. You take all the newspapers and try to put a thread over it and then start burning from the all sides, 4 sides. What will happen if you burn the paper?
Quite easily, sir.
It will burn quite easily initially.
So the
Afterwards, what will happen?
from
Initially,
the
it will be
to
difficult.
inner.
Afterwards, what will happen?
It will spread throughout the paper, sir. It will spread to the every part.
Afterwards, still after some time,
You'll have ash, sir.
ash. After
Yeah.
some time,
Complete
after some
combustion.
time,
Sir,
After-
complete combustion will happen.
complete
After that,
combustion will happen. Sri Vignesh, you don't talk. Other people, I want them to respond. Yeah. Complete combustion will happen. How many people will tell it is complete combustion will happen? So you get only ash, that is dark color, that is black color ash, or
No,
how many
sir.
people? Tell what will happen?
In center, the papers are unburnt.
Super. Why it is not happening?
Sir, because
Because you put fire, right? You put fire all around. So outside is burning. Center, why it is not burning?
sir, because the sufficient oxygen is not.
Why sufficient oxygen is not there? It is put in the atmosphere, right? Yeah,
Yes,
everywhere
sir.
oxygen is there, but still why it is not going inside?
Sir, because the outer paper as are covered.
Outer paper.
Outer paper burned as covered the center things.
What is your name? Can I get your name?
Raj
Yeah.
Vignesh, sir.
Raj Vignesh. Super Raj Vignesh. All of you, please give a big round of applause to him. He told what is happening. Oh, good. Yeah. Any other people? Why the center paper is not burnt? You know, right? Center paper will not burn, right? This is what you might have done recently in Bogie also. So you will be burning with all the waste which is there in your home. You will be going on doing one stick and then try to put the flame around it. Am I right? Otherwise, if you are not doing, it may not get burnt. Correct? Why it is happening like that? Any idea? Yeah,
Yes, so the
it's
acts
open.
as like an insulation layer almost. It doesn't let.
Ash, very good, very good. Ash acts like an insulation layer. So what will happen? What type of insulation it will happen around it? Yeah.
Insulation from the heat, no, sir.
No, how the burning is taking place? How the burning is taking place? No? Yeah. How the burning is taking place? Yeah. Can anyone talk there? Yeah.
I'm not exactly understanding the question, sir.
You are not able to understand the question. Good. Yeah. Any other?
So by temperature difference.
temperature difference. Now, can anyone tell this? No. Now, I am showing you some pictures, right? I'm showing you some picture now, right? Yeah. Yeah. Now, what is happening? Now, if you take a coal, you know, right? Coal, black color, coal burning. If you burn the coal, what will happen? You get ash, right? Yeah, all of you are with me.
Yes, sir. Yes, sir.
You get ash, white color ash form. Inner, there will be a black which is unburnt. Am I right? Is it correct?
Yes, sir.
So now you take, this is the coal, right? This is the coal, a spherical coal I am taking. I am burning it. So what will happen? Entire outer surface is exposed to the oxygen, the surrounding oxygen. You are firing it. Therefore, oxygen, in presence of the oxygen, it gets fired, leaving the ash like this, right? After some time, there will be ash formed over it, and then inside there is a core which is unburnt. Am I right? Correct. Now, if this to be going, if this to be burnt outer, that is inner, the oxygen should penetrate through this pores. Am I right? That is the ash. Then only it should reach this surface. Once it reaches this surface, then only the firing will occur. Otherwise, what will happen? If the oxygen is not able to penetrate through this, there will be no oxygen left here. Therefore, the burning will stop. You get an unburned coal here. Am I right? Inside. So if the ash is loose, that is ash is, the thickness of the ash is loose, then what will happen? The gas will penetrate through this and then firing will happen. So I assume that the ash layer is porous. So with the time, it goes like this. Only at the center part, there may be unburnt, or after some time it gets burnt. Now, here, one important thing is when the ash is formed, your gas should penetrate through this particular ash layer. Then only the firing will happen here, because oxygen, it should have oxygen here. Then only it gets fired. If there is no oxygen at this particular level, if the oxygen is there in the outer surface, then this firing will get stopped. It won't get burnt at all. Therefore, your rate of a reaction, that is the burning is happening, the rate of a burning will depend on how much the mass is being transported across this particular ash layer. That is why mass transfer takes an important role. How much mass is being diffused through this, it will come by your Fick's law. Understand? So mass transfer, how much is being transferred here, then according to that mass, how much is the kinetic part. These both will combine together, will give you the rate of a reaction. Yeah. Any doubt? What? I hope I cleared my, or you had still, I made some more confusion to you.
Sir, so the more we powder the coal or any combustible material, the more efficient the heating will be.
That because of the surface area increased, right?
Yes, sir.
That
So
is what you will be studying in mechanical operation, where huge lumps of material is powdered to give you more surface area. Therefore, wetting will be more. Yeah, it's like that. But here you are not making powder, right? The solid is same. Now you take a coal. You burn the coal. One coal particle, spherical particle coal you take. You burn the coal. What will happen? Outer you get ash, white color. Then what you do? You do. That is outer layer you remove. Then inner will be again black, right? If you remove that ash, then what will happen? Again, oxygen will penetrate through the inner thing. Then it gets burnt. for suppose you're not removing that ash, what will happen?
Combustion will die down.
Yeah, die down. I can give one more example, but I should not give that example. Sorry for giving that example. To make my point clear, I'll give that example, but don't tell this example to anyone. Okay. I'm sorry for telling that example. Again, I take your permission to give that example. Okay, let me take that example. You take a cigarette, right?
Okay.
Yeah, cigarette. I should not give that. I'm very sorry for giving that example, but to make my point clear, I need to give that. Because a lot of people observe it. So you take a cigarette, you fire the cigarette. Then what will happen? It will form as ash. Am I right? Now, if you're not removing that ash, what will happen? The burning will take very slowly. That is why the people will remove that ash, so that the fire will have oxygen, so that it gets burnt. You take two cigarettes, one you put both you light at the same time, one you remove the ash and one you don't remove the ash. You see which will fire fast at the end, till end. The ash which is removed, it will fire fast because the rate will be more, because the surface is exposed to the oxygen, then it gets burnt fast. That means the rate of a reaction is much faster. But when there is ash which is being formed, and if you're not removing the ash, then what will happen? The gas should penetrate through the ash. So ash will add extra resistance for the oxygen to penetrate through it. Therefore, the rate will be very less. Did my point clear?
Yes, sir. Yeah, got it, sir.
Now here you see, I'll show you one more. When there is a catalytic reaction, there is two types. One is progressive core and shrinking core. Now you see here, this is a solid surface. On getting, don't bother about all this. This we will discuss later. I just want to clear my point that not only in kinetic part, mass transfer plays a very important role. That is the crux of the thing what I am going to express, right? Try to understand that alone. Now this is a solid. There are two types of solid now. When the solid is getting reacted, the solid can change its size. There can be an unchanging size or changing size. Let us see unchanging size. So this reaction, what will happen if the react with the time, the reaction is happening. So the reaction, you can see the dark color. That means it is fully converted. This is fully converted, but the size of the particle is same. Size of the particle is same, whereas this particle earlier it may be like a calcium carbonate. If you see, you take a calcium carbonate, solid, you heat it, then what will happen? Calcium carbonate is not a porous solid. If you heat it, CO2 will be released. CO2, when it is getting released, it makes the solid porous and comes out. So the size of the particle remains the same, whereas this fellow is a hard solid. This becomes like a porous. So the size is won't change. This is one type of reaction where the size is not changing, whereas it forms a ash layer over it or porous. There is one more. Size goes on changing. Now you see, this is the original size of the particle. After some particular time, what happens? This is the original size of the particle. This is the next size of the particle, because this ash is formed. You are not removing the ash. Ash is not a reactant, am I right? The reactant shrinked its size. After some time, you can see this is only the unreacted core. Till after some time, this is only the unreacted core. So what is happening here? This much of the solid is shrink to this, and it is shrink to this, and afterwards it becomes a point with the time. So there can be two types. That is, one is the solid gets changed with respect to the time. The other one is the solid is not changing with respect to the time. When the solid is not changing with respect to the time, then what happens is the hard solid can become porous. That is, the density will change, because here the density, it will be you calculate the density, it will have some X. Final product will have a density which is much lesser. One example I can give. You take a, what do you call it, cake batter. Cake batter, everything you are putting, it will be like a liquid. Am I right? The density of the liquid will be much greater there. But once you bake it, what will happen is this becomes porous. Am I right? Because CO2 is being released, because that is why you are putting that baking powder or baking soda. So when the CO2 is getting released, what will happen? It is penetrating through the, what do you call that, liquid part. So it makes as a porous. You can give an example of even your vada. Vada you put, it is a solid vada. The moment you put in liquid, what will happen? It becomes porous. But the size is same almost. Okay, due to the cooking, the size may a bit increase. But what my point is, solid particle is becoming as a porous. Whereas this particular thing, your best example is coal or cigarette or whatever it is. Yeah. Any doubt? I think now I made my point clear. Not clear still. Yeah. I'm waiting for your some.
Yes, sir, we got it. Makes sense.
So here, unlike your homogeneous reactions, here extra mass transfer also plays an important role. Other than C. Vignesh, someone else I want your feedback, because only he is giving some feedback. I don't want him to give the feedback. Sri Vignesh, when I ask a question, don't give you feedback. When I ask something related to the class, you give. Okay. Yeah, I want some other participation so that it becomes lively. Yeah. Any other? Emma? Did I make my point clear, or still it is confusing or something? Yeah, you have to understand this. Otherwise, if you understand this, then your life becomes like a movie, seeing Rajinikanth movie. If you are not understanding this, mass transfer plays an important role, then your life becomes, your CRE becomes like a Matrix movie. We don't know what is happening here and there. Yeah. So along with the mass here reaction rate, you have to discuss about the mass transfer also plays an important role. That extra resistance offered because of the mass transfer resistance, you have to take that into picture in the minus RA equation. Earlier you are writing minus RA is K into Ca. K is the temperature dependent term and Ca is the concentration dependent term. So if the temperature is constant, then you are writing minus K RA is equal to K into Ca. Ca is Ca naught into 1 minus Xa, and trying to find out your Xa with the time. That you cannot do now. Your RA should have one more component, that is mass transfer component also should come along with the temperature term and concentration term. That is what my point. Yeah. Anyone? Any other people I want?
Could you repeat that last part, sir? The one about RA?
Minus RA is K into Ca, right? For a homogeneous reaction.
Yes, sir.
It depends on the order of a reaction. If the order is 1, minus RA is K into Ca, correct? A
Yes,
gives
sir.
R.
Yes, sir.
If there is no temperature, if the constant temperature, K also will remain same. But if there is a heterogeneous reaction, you cannot write like that. Minus RA is K into Ca. You have to write K into Ca into something else. That extra term is what you will be studying in. What to write that extra? That is, you have to get the mass transfer coefficient also into picture. How to write that mass transfer coefficient for a different types of reaction is what you will be studying here. Okay.
Got it, sir. Got it.
Yeah. If there is a gas liquid reactions, what will happen? Since the gas is absorbed in the liquid, if the liquid is taking part on a solid surface or whatever it is, if there is some X amount of reaction is happening, because of the presence of the absorption, that is, gas is absorbed in liquid, then what will happen is the mass transfer gets enhanced, or the rate of the equation gets enhanced because of the absorption of gas in the liquid. Liquid is giving some product in presence of a solid catalyst. You compare that with liquid which is having gas present in it. Again, the same reaction is happening in terms of a catalyst. If you compare these two, that is gas present in liquid, gas absent in liquid with the same catalyst, the gas present in the liquid, the mass transfer or the rate get enhanced because of the mass transfer, which is absorbed in the liquid. That is, the gas is absorbed in the liquid. Therefore, that is why you get that enhancement factors, especially for gas liquid reactions. The rate will get increased, whereas the other types, the rate gets decreased because of the mass transfer resistance. Since the absorption is happening inside the liquid, which is taking part in the reaction, therefore the reaction gets enhanced. That is why you get enhancement factor, especially in gas liquid reactions. One more example is ammonia plus aqueous nitric acid will give you ammonium nitrate. Where you saw this reaction, this is in fertilizers, right? You manufactured this ammonium nitrate. Ammonia is absorbed in NHCO3 to give you that ammonium nitrate, right? The other one example is chlorination of liquid hydrocarbons. These are some of the example of gas liquid reactions. In the gas liquid reactions, remember that your reaction rate gets enhanced because of the mass transfer. Whereas the other combinations, your reaction rate will be decreased because of the mass transfer. Generally, A gives R and A gives R. A gives R homogeneous and A gives R heterogeneous. Your rate of a reaction of a homogeneous is much more than heterogeneous generally, because in heterogeneous mass transfer will play an important role. Therefore, your rate will get decreased. That is why the Thiele's modulus will come into picture. How much the rate is decreased because of the mass transfer. Whereas gas liquid heterogeneous reaction, because of the presence of the gas which is absorbed in liquid, the rate gets enhanced. So you again take A gives R and A gives R. One is gas absorbed and the other is gas not absorbed. Gas absorbed, your rate will be much greater than the gas which is not absorbed. Therefore, you get enhancement factors, which is greater than 1 for this. Whereas gas solid reactions, catalytic solid, you get rate much lesser than homogeneous. Okay. Yeah, this is one example. The other reactions are also there. Liquid reactions. You can see soap preparation. That is acid plus alkali. You get soap. This is a solid. So this reactions also again mass transfer plays a very important role. Nitration of organic compounds. This is one more example of liquid reactions. There can be a liquid solid reactions also. Calcium carbonate and plus H2O will give you acetylene, right? So these are some of the examples of non-catalytic homogeneous reactions. I gave different combinations here. In book, if you see, a lot of examples will be there. Please go through that examples, right? So this is liquid solid, liquid, gas liquid or gas solid, right? So some different combinations.
All right, sir.
Yeah.
Sir,
Yeah.
sir, it says heterogeneous reactions, but then it says liquid there.
Liquid.
No, sir, the heading is non-catalytic heterogeneous.
Yeah.
And
Yeah, what is it?
no, it says liquid, sir. So
Liquid.
how is it heterogeneous?
It is happening in presence of a catalyst, some solid catalyst.
Sorry, sir, I can't hear you.
It is happening in presence of a catalyst because it can happen in presence of, or the product which is coming is it will be a solid. Because
Okay.
liquid is nothing but reaction. Liquid, two liquids are getting reacted to give you a solid product.
Okay, sir.
some change of phase where there is no catalyst at all. Some solid may form. This acids and alkali will give you soap, which is a solid. Both are liquid, right? Okay. Oh, this you are telling liquid, since liquid, how it will be heterogeneous. That is your question?
Yes, sir.
Yeah, liquid reactions is giving a solid product. Because I told heterogeneous, either the reactant can be at different phases or the products also can be at different phases, right? Even one different phase is there, then it is heterogeneous. Yeah, did I answer your question or confused?
Yes, sir. I got it, sir.
Okay. Any other? Any other? Mm, 10 more minutes. I'll just leave you because I think someone gave this. Understood, sir. Okay, you are sending me message through this Ashresha. Okay, Ashresha. Okay. I think no request. Okay. I'll just wind off with this particular slide. Yeah. Now, what is the difference between this homogeneous and heterogeneous, right? I have to give that. I gave some examples. This is the rate. Number of chemical steps, series or parallel. If you consider it is a parallel step, then overall rate is nothing but the sum of the different rates, right? If there is a series reaction and if there is a steady state condition, then overall will be R1 is equal to R2 or is equal to Rn, because this is a series of number of steps. This is the heterogeneous reaction, right? If there is a heterogeneous reactions, if there is a parallel reaction, then your overall reaction will be sum of the reactants, sum of the reaction or reaction rates. If there is a series of steps involved, then your overall reaction will happen R1, that is the rate in first step is equal to the rate at the second step, is equal to the rate at the third step, is equal to the rate at the nth step. This particular thing you will understand when we go for derivations, because in a heterogeneous reactions, we assume all reactions are series in nature. Therefore, the rate at 1 is equal to the rate at the second step. That is what you will be equating and doing the derivations. That we will see when we go for the derivation part. Okay. Don't bother about much about this particular thing. If there is a heterogeneous reaction, you can write the rate like this: 1 by V. V is the volume of the reactor. We know this. Minus RA is minus 1 by V into dNA by dt. Na by V, V is constant, therefore it becomes Ca. In the homogeneous itself, we got it. But if there is a heterogeneous reactions, what will happen is, instead of V, W can come, that is the mass of the solid which is taking part in a reaction or a catalyst, or S can come. S is nothing but an interfacial surface area. Interfacial surface area, because here, if you see the other one, that is, this absorption gas is absorbed in liquid. Therefore, there will be interface of the gas and liquid. The interface, how much is the interface? Based on that, your reaction rate will change. That is what is this. That is what is this. How much is the interface surface area between the two phases? Based on that also, you can write your rate. So you can equate all the rates, because DNA is nothing but the moles of A reacted. Then it will happen as minus RA into V is nothing but minus RA dash into W or minus RA double dash into S. Once you know one particular rate, the other rate you can calculate if you know your W, weight of a catalyst, or volume of the liquid, or the surface area of an interfacial surface area. If you know, you can calculate the rates, absorbed rates differently using this expression. This is all in the last class itself, CRE1 we discussed, right? this is one important thing. Here, what we call in the CRE1 is RA, RA dash, and RA double dash. We call this RA double dash, triple dash, or something dash is nothing but the absorbed rate. Absorbed rate or global rate. Whereas this you call it as normal rate, right? Whereas due to the mass transfer, you get extra RA, that is the rate of a reaction, that in general in CRE2 heterogeneous case, you will call it as absorbed rate, OB, absorbed rate, OBSE, observed rate, or global rate, right? That is what, how to calculate this is what the CRE is all about, CRE2. Okay. Yeah, I think I'll stop here. Then we can go for the how this mass transfer is playing an important role in the next classes. Okay. Yeah, I completed my part. I don't want to take more time for you because since today is the first class, I'll try to download the attendance and show how much it is coming. I don't think it is getting downloaded. I don't know how to do it also. Yeah, Vignesh, I think you can start taking the attendance. 58 participants are there. Just give who is absent, but we'll give attendance for them today. In the next class, we'll see because there is some login issues and all. 58, I think 10 people are not there. Okay. Yeah, any other doubt, ma? You are having? Yeah. I stop here. I don't want to continue. I stop the recording. Stop the recording. Yeah.